All right, guys. So JavaScript, we've been using that a lot, but we will also be using Python a lot. I've mentioned this to a few students, but and I might have mentioned this earlier. Once you know one coding language, it's pretty easy to learn a different coding language. Now, that's not just like something that we've been brainwashed to believe. It's really true. Like I am new to Python and JavaScript. My background or my preferred language is C++ because I've worked with that for many years. But learning JavaScript and Python has been pretty simple because I have that core understanding of C++. So, don't worry about, don't treat this as like you're learning a totally different language. It's more just like, I guess the way I'd explain it is you're not learning French and like Japanese when you're learning in Python and JavaScript. It's more like you're learning French and maybe Canadian French. So you're learning like a dialect of the same language. So a lot of the same concepts that you know in JavaScript, like for loops, if statements, basic data types like ints and strings, you're going to see those same things in Python. So again, don't feel overwhelmed like, oh no, I got to learn a whole new language now. It's going to be pretty easy to adapt to it. The hardest parts will be like syntax, like, oh, do I use curly brackets here, or do I use some other delimiter? Do I need to push into this array, or do I need to use append to get into this list? So small stuff like that. It might be a little cumbersome early on where you're using both languages and you gotta constantly think, do I got to use console.log to get to console or something else? So that's probably gonna be your hardest challenge, hopefully. The language itself, there's some differences from JavaScript, but for the core part of it is going to be familiar to you guys once you guys see the language and get used to it. All right, can everyone see my screen? I hope so. All right, if you guys can't see my screen, just give me a shout out in November questions, but I think I should be sharing correctly. So let's get into Python. So just a brief history of Python before I get started with showing you guys code. It was released in 1991. It was developed by a guy named Guido Rossum. Hopefully I pronounced his name correctly. He actually started working on it in the late 1980s. I think he just wanted a coding language that could solve his needs, and he kind of started developing this for his own needs, but then he realized this could be, very useful for other purposes. So he kind of released it in 1991. It is actually named after Monty Python's Flying Circus. It was one of his favorite shows from the 70s. So that's the origin of the name. If we go look at the logo, also we have like this logo, which is basically like two snakes intertwined, looks like a plus sign. But that's where the Python theme comes into play. But yeah, it did come from Monty Python show. Origins of the language, or I guess the purposes. It was designed to be easy to use and easy to read. So this is, if you ask many developers, a lot of them will say Python is on the easier side to learn, and I would definitely reflect that sentiment because I think it feels more natural when I'm writing it. It's just easier to do. It's quicker to write. There's less like, I guess you don't have to worry about curly braces in Python. It just seems it's easier to get your ideas onto the screen with Python, from my experience, and I think other developers would say the same. So yeah, it's definitely on the easier side to understand, use, and also when you're reading it, it's much easier to read compared to some other coding languages out there. In terms of use cases, Python is very flexible and used in very many capacities. From just quick reading of it, it's popular in game development. It's used for backend development like database and server connections. Machine learning is popular with Python also because it's, again, very, human readable, but also, computers can process it easily also. Data analytics and math computations are also very popular with Python. So many use cases for Python. That's also why it's very popular. You can adapt it for your needs quite easally. When comparing it to JavaScript, there are a lot of similarities. So I'm not going to go into all those. Just general couple items, like they're both high-level languages, which means they kind of abstract away a lot of the details for your working with your CPU or your machine there. So that comes at a cost. So basically, we have like easy data structures to work with, and we don't have to worry about like types, strict types too much. And that's because it's kind of auto-magically done for you. The interpreter handles that and kind of converts it down to lower languages so that your CPU can process the instructions. But the cost with that is that these languages, both JavaScript and Python, tend to be slower in terms of execution speed compared to lower level languages like Java or C++, for example. You don't have to worry about that too much. I mean, for the most part, we're not doing low latency items. So latency being like time duration. So we don't need to worry about, do we need to use C++ or Python? For our needs, for web development, Python and JavaScript are gonna get the job done for us. So just something to be aware of. Both languages are dynamic, and as kind of mentioned, they use interpreters. So instead of having a compiler that kind of checks everything during compile time, it's a lot of this is done during runtime, and that kind of just makes it as more dynamic. You don't have to tell your interpreter like, hey, this is going to be an integer or this is going to be a string. You could change that on the fly during execution, and for the most part, it's going to be fine. All right, so those are some basic similarities. Again, there's probably a lot more. You guys can Google that if you guys are more interested in knowing the differences or the similarities and differences. I will highlight some differences because those are probably more important to know about. I think Chad covered this yesterday. He mentioned JavaScript uses something called hoisting, which basically means you can actually use a function before you actually declare it. That is not true for Python. So I guess my first example will be if I create a function, which I'll go into the syntax, so don't worry about that too much. If I create a function and that does return hello, and if I try calling that function before I have it declared, which just means above it, let's see what happens. So to run Python code, you're going to have to use the Python engine and type in your file name. So it's intro.py. And I got an error, not the error I wanted. That is bad syntax. All right, so I got this error, name error. My func is not defined. That's because this is executing top down, and there's no hoisting, unlike in JavaScript. So in this case, it had no idea what my func is at this point. And I wish I could type correctly. Let me try that again. So I get the same error when I spelled it correctly also. But basically, yeah, so it has no idea what my func is at this point in execution. Until it gets here, it won't know. So if I switch the ordering of these, it will work fine. Fingers crossed. Let's clear my console, run that again. Of course, nothing got printed. Sorry, again, don't worry about the syntax here. I'll definitely talk about what I'm doing, but a lot of it should be familiar from JavaScript. So I printed out hello to the console. All right, that worked. Again, so I had to declare my function before I could actually use it, which is different than JavaScript. You can do it in any order, and it kind of works because of hoisting in JavaScript, which does not exist in Python. Other differences, just generally, Python has more built-in libraries. So again, that goes back to the more ease of use. Like if you guys kind of encountered this during the Deaf Grandma challenge, we had to use a different package or module, the prompt module from via NPM in order to get input working with Node. That's not the case with Python. It's kind of built in. There's an input mechanism. There's a lot more built in. I mean, that's just one example. But like other items you might want to do with JavaScript, you might have to include another module or get a third-party module to kind of achieve what you want. Python has more of that built in. The way I've seen it described is Python is more a batteries included language, so you just kind of can get up and running quicker. Again, that goes back to the ease of use, which I definitely appreciate. If you've ever developed in C++, it's definitely sometimes cumbersome to find the right includes to have in your file to make sure you're using the functions you want. But Python just makes that very simple, which I'm very appreciative of. Another difference between JavaScript and Python, and I kind of got to watch my words here, but I would say Python is more of a traditional object-oriented programming language. And again, if you don't know what that term means, that's going to be the focus of week 2 in our curriculum. So don't worry if that's foreign language to you at this point. But yeah, so it uses class-based object-oriented programming. JavaScript is technically an object-oriented programming language, but it's not in the typical style that most developers would tell you about. So I don't want to say JavaScript is not object-oriented programming, but it wasn't designed in that manner. It was more designed to be a scripting language, whereas Python is more flexible. You could use it functionally, use it as a scripting language, or use it in a more object-oriented programming way. So again, that just highlights the flexibility of Python, as I said. One other key difference between JavaScript and Python. So the way I describe JavaScript, I would say, is like it's the wild, wild west. There's really no rules. I mean, there are rules, but it's way more loose than Python. Python is what I describe as strongly typed versus JavaScript is weakly typed. And what I mean by that is when it comes to conversions. So if I go to my JavaScript file and if I do something like, let's see, create a variable, let my value equal hello plus 1. All right, so in this case, I'm back in JavaScript, just to be clear. I have a string, and I'm adding a number to it and assigning it to my value. So if I ran that, and I want to print out console.log my value. Let's give that a run. So node intro.js. Intro. All right, so I got printed out hello with a 1 appended to it, and this is a string. So that totally worked fine. The reason being is because JavaScript kind of implicitly converts values for you and kind of gets to the work. This is not the case in Python. So if I want to do something identical to that, let's say I have a variable, and I'll go into declaring variables, but just let you know off the bat, I can just say my value. I don't need to use a let or const or var in Python. And let's do the same thing. We have hello, and then let's try adding 1 to it and see what happens. And if I want to print out the screen, I use something called print. And I know I kind of glazed over that, but print will get you your output to console. And let's say I want to put my value up there. Let's give this a run and see what happens. Oh, I got an error. So I got a type error. It says can only concatenate string, not int. So here I'm adding an integer value to a string, and it failed on that. So this is another highlighting the differences. JavaScript will kind of magically try to make it work for you, and if it doesn't work, it won't even alert you most times. Python will have those errors, so you kind of catch them ahead of time. So I like Python because I feel safer when I'm doing it. Like JavaScript is much easier to make mistakes, but then again, it's a trade-off. You could do a lot more, things flexibly in JavaScript, like kind of, with your rules, you have, more leeway into what you want to do, but also that comes at a cost. Like it's potentially more dangerous. The cliche quote of with more power comes more responsibility. So keep that in mind in both JavaScript and Python. If I did want to get this to work, I would actually have to manually convert this 1 to a string. I actually forgot the syntax for that. It might just be something like toString, converts number to string in Python. Again, Google is your friend. I Google all the time. Don't feel bad if you're Googling methods. It's just good to know about how to go about it. So in this case, str will convert a number to a string. So hopefully, I think once I've done that conversion explicitly instead of relying on the language to do it implicitly, I think it should work. So let's run that again. And yep, got my output. That's what I wanted, but I had to manually tell Python that I want this to be treated as a string. So that's another difference between JavaScript and Python to be aware of. Python is more strongly typed. JavaScript is more weakly typed. That's what those terms mean. Kind of going off of what I mentioned before, Python will have more exceptions thrown, as in if you try to do something that's bad or dangerous, it will more likely than not alert you, or if it doesn't alert you, it'll kind of break your program, which sounds bad, but it's actually good that you catch a bug. Rather than JavaScript, if something goes wrong with like a computation, it might just continue on as if nothing bad happened, and then that could lead to worse problems down the line, depending on what your application is doing. So keep that in mind. Again, with JavaScript, things can go wrong easily, and you might not even know it. In Python, you're protected a little bit more by the language inherently. A couple other small differences I just want to highlight. There's some this is more. It's more into the syntax. I guess the small granularities of Python and JavaScript. So in JavaScript, doing something like if I have let I equals 9, I could do something like I++, and that increments I. That notation does not exist in Python. Again, it's a small thing. Just like if I want to do I equals 9, if I want to increment it, I'd have to do something like plus equals 1. I can't. The I++ does not exist. It'll give me an error if you try to do that. So just be mindful of that, because we use that notation often in JavaScript. Another key difference, if you're familiar with the undefined type in JavaScript, that's again goes back to like the exceptions and just the wild west nature of JavaScript. There's no such concept of undefined in Python. You have to have values. Like I have to give this a value. If I don't want it to have a specific value, I would go with none. We'll now get into what none means. But yeah, there's no concept of undefined. Some other smaller things, just to quickly go over them, not spend too much time on them. But there's no switch statements. If you're familiar with switch statements in JavaScript, that does not exist in Python. To alleviate that, you just have to do if else's. And as I mentioned before, there's no implicit conversions. So in JavaScript, if you're familiar with the equal equals versus the equals equal equals, if you don't know the difference between these two in JavaScript, great question to ask during discussion time. You should definitely know the difference between these two in JavaScript, what they do differently, kind of how they behave, and what they're trying to achieve. With that said, in Python, you just have equal equals. You don't have to worry about implicit or explicit conversions the way JavaScript does. In this case, equal equals will just do your comparator for you. And there's only one side. You don't have to, there's no triple equals. It doesn't exist in Python. So those are just some basic differences. Again, there's probably a handful of them, but those are just ones I want to highlight at this point. All right, so enough talk about JavaScript. We're done with JavaScript for now. Let's talk more about Python because that's our main focus here. So let me get my notes correct. All right, so the first thing I want to do, as with many programming languages, I'm going to create a simple hello world application. So to start, I'm going to make it very simple. I'm going to say hello world. And just to reiterate, if I want to run this, you type in Python into your console and then the file name. And again, make sure you're in the right directory. In this case, all my files in the same directory, so I don't have to worry about that. If I run that, I should get the output of hello world. So just going over what this is doing. Strings are in double quotes. They could also be single quotes, and I'll reiterate that later. So these are that's the same thing as before. Print just takes in an argument or multiple arguments. So I could do doing this. I could do hello and then world here, and I think that will put it on 2 different lines. So there'll be a new line between each of those. I'm sure. No, it's the same line. I lied. So it appends them with a space, which is great. That's probably better as to what I wanted. So yeah, print takes in 1 or more arguments and just prints out the console. It's very similar to console.log from JavaScript. So let's spice this up a little bit. I'm going to create a variable. So to declare a variable, you just put in the name of what your variable has to be. Again, you don't have to bother with lets or const or var as you have to do that in JavaScript. This, I just create a message and write what I want. So let's say hello November. Platoon. And then print that out. So nothing too complicated going on here. I assign a value to my variable and I'm printing that variable out to console. Nothing too crazy to see there. We say hello November Platoon. For that, let's get into input output. So as you probably saw with the Def Grammar challenge, input through node is not trivial. However, with Python, it's built in, nothing fancy. So let's say I wanted input from the user. Well, let's say I wanted the user's name, my name, and to get input, I simply use the input function. So it's input lowercase parentheses, and then I'm gonna have a prompt. So I'm gonna say enter your name, please. All right, so this will actually halt your application until an input is received, or like if they just hit enter and don't enter in anything, that's fine. So yeah, we're gonna get a name, and then let's say hello to that user's name. So to keep it simple, I'm gonna use string concatenation, which is the plus symbol. My name. Let's add some exclamations, because we're happy about that. All right, so just to go over what this is doing, I'm getting an input from the user from the terminal, storing it into a variable that I called my name. Again, I could have that be whatever I want. I also have another variable called message that I'm building a string using plus operators to concatenate the string, and then putting that message out. One thing I want to highlight here, this is another difference between JavaScript and Python. This is not a required difference, but it's it's coding style. Within Python, you use something called I think it's called snake case. Let me look this up before I butcher it. What is the name of it? Case style.
Yeah, it's snake case.
All right, thanks, Tom. Yeah, so this is called snake case. If you kind of imagine it, it's like a snake kind of winding its way. I don't know. But basically, snake case requires lowercase letters separated by underscores. I guess you could use uppercase letters in certain cases. There are style guides for that. So Python has their own style guides. So these are recommendations. You can kind of name your variables however you want, so as long as you don't break their requirements. But for the most part, you want to use underscores, which is different compared to JavaScript, where you use camel case or mixed case. Just to highlight that, what the differences are, as you probably noticed, like I have my value instead of separating with an underscore. You know, each new word uses a uppercase to start, and then just lowercase for the rest of the way. If I wanted to write the same thing here, I would say my value here. So again, underscores, lowercase, that's just the standard. Please try to follow style guidelines. We'll get more into that style later, but it's good to be consistent. When you're sharing code and reading code, it's good to just have the same, I guess, syntax and language that you're reading rather than, dealing with 50 different variations of it. So that's just a style guide. Again, you don't have to, but just follow style guides if you can. All right, let me change this back to my name and run this quickly. And I think this is simple enough, so we won't keep doing hello world. We'll get into more complex things. All right, so it's prompting me now. So my execution is paused. It has not executed these two lines. Let's give my name, Encore. Great, said hello to me. I feel special. My program's talking to me. So that's a simple hello world with input output. Declaring variables, again, you don't have to use let or const. You just create something, assign it, and you're good to go. Simple, easy to use. Again, another great feature of Python. All right, so we talked about user input. We talked about variables and printing out to console. Let's get into more of the nitty gritty. Let's talk about, I guess, one more thing I need to highlight, comments. Comments are done via the bash key, or I guess the hashtag key, which is shift3. That's how you write comments. So this is my comment. That's different than JavaScript. Obviously, you use double pipes. A good Visual Studio Code shortcut to know about is if you want to comment multiple lines of code. So let's say I have X, Y, Z, whatever. Let's say I have a bunch of lines. If I want to comment the entire block, you could do this in JavaScript or Python or any language within VS Code. So it's VS Code specific. If you hold command and / it will comment the entire block for you. And then if you hit that again, it'll uncomment it. So it's really useful when you want to just like remove a bunch of code, but don't want to delete it from your code base. So that's how you write comments. Comments, again, very good practice to have in your code to tell the tell yourself and other readers of your code what certain code blocks are doing. So definitely comment your code, regardless of what language you're working in. So let's get into some data types. So data types, Python. The first one I want to highlight is called none. So let's create a variable and assign it to none. So none is essentially equal to the null value of JavaScript. They act in the same manner. So I'm specifying a value, and that value is none. Now, again, this is not the same as undefined. Undefined means it has no value, and we never bother to assign it. Here, I'm clearly saying that Z has a value of none. And this none is the same none objects anywhere you go. As in, if I have Y equals none, both of these are pointing to the same exact instance of none, because there's only one instance of none. There's not multiple copies of none being created. This is a immutable type, meaning it can't be changed, and it's only one existence of it ever. So none, hopefully that is pretty clear. You just use it if you don't have a value in mind to set, you set it to none. Let's get into Booleans. So Booleans, I think we're pretty familiar with. Again, we've encountered these in JavaScript, so nothing too surprising here. The only difference is that for true and false, you want to use a capital T for true and then a capital F for false. And VS Code will autofill you in for this. So like if you noticed before when I was typing in JavaScript, I used an uppercase T initially, but it auto-corrected for me when I used the autofill. I don't know what to call this. We'll call this donuts equals false, which makes me sad because I like donuts. But yep, true and false. Same thing with none. There's only one instance of true and one instance of false. So you're not creating multiple copies of false. Like if they're all pointing to the same value. The reason that's important is because when you're comparing values, this gets into theory versus practice. If I have Let's say I have some variable called y. Let's equals 5. If I want to see if y equals none, one way to do it, I could say if, and we're into if statements, y equals none. Do something. This will work if like y equals none. This will work, but in practice or in theory, you want to say is none. The reason being is because you're looking for identity, not equivalence. And that's, again, maybe it's probably too into the weeds at that point. But usually, whenever you're comparing none, use is none instead of equals none. And again, it's kind of minutia there. This will still work in a lot of cases, but in practice, use is none. The same thing goes with true and false. Instead of saying, if blah equals, and it's not going to work because blah is declared lower, true, this will work. And honestly, I do this all the time. I use equals with true. But technically, you should be using is because it's an identity, not a equivalence comparison. And if I lost you guys there, I apologize. You don't have to worry about that too much. Just use is none if you remember to do it. All right, so we have Booleans. Let's move on because Booleans aren't too exciting. Let's get into numbers. So another difference between JavaScript and Python. Python actually has several different types of numbers. In JavaScript, every number essentially is a float value. I guess that's not true because there's a big int type now, which you might have used for factorial. But in Python, there are ints. So let me declare an int 6, and there's something called floating point numbers. Cannot type. So those are delineated by having decimal precision. So in this case, my integer is 6 exactly. My float is 6.74. So you can still combine these. So like if I wanted to, do a simple addition and print out the console, I could do my int plus my float, and it's gonna convert it to the lowest type. So there's implicit conversion between numbers. I know I said there's explicit conversions most of the time. Yes, that was gonna blow up to me. What happened here? Indentation, right? Not function. That's another thing I need to highlight. Thank you for reminding me. All right, so I printed out the addition there. I got 12.74. So basically, this result became a float value. We'll get into delimiters later, I guess. I just want to go through data types. Just to highlight this, I'm not going to get too into it. There are other types of numbers out there. So we're used to the decimal system, but there are many other systems out there. Binary is what your computer talks in. It's ones and zeros. Hexadecimal is really popular also for notation. So you could do those also. So let's say I want a binary number. Let's call it my binary number. To do that, you need to prefix it with a 0 and a B. So you kind of see the color change there. And these can only take ones and zeros. So like, if you guys remember your binary, don't worry if you don't. But I remember the CS50 course. If any of you guys watch that, they have a nice section on binary numbers in the first lecture, I believe. So this is equal to 5 in decimal notation, but we have it in binary. So if I did print this out, it'll actually do it in decimal. So that's a good way to check. And this kind of makes it more, human readable because, humans, you and I, usually are used to decimal numbers. So let me print that out. Should be 5. Yep. So this is by. Please go away. All right. This is equivalent to 5 in decimal. If you don't remember binary numbers, I'm going to say definitely brush up on them. You're not going to need to know them, but they're good to know about. The last one I'm just going to go over is hexadecimal because you're going to see this often, especially like in CSS. Hexadecimal numbers are used to represent colors, for example. I'm just going to call it my hex equals. To do this, you need a 0 and an x, and then hexadecimal numbers are like decimal numbers, but they have additional digits. So they have hexadecimal equals 0 through 9, but they have more. They have A, B, C, D, E, and F. So in addition to your standard 10 digits, 0 through 9, you have 6 more digits. So you have a total of 16. So essentially hexadecimal is, or not essentially, it is a base 16 number. So if I want to declare one of those, I could say like 9, A, B, 7. I have no idea what this is in decimal, but luckily if I print that out, it'll tell me what it is in decimal. And all right, so it's 39,607. Great. All right, so if you have questions about different notations, you could do your own research, Google. Again, great to have that out there. So moving on from numbers, let's get into strings. I'm gonna do some code to free up some space. Let's talk about strings. So strings, pretty familiar with them with JavaScript, a lot of the same essential methods. So if I wanted to declare a string, I could call a variable, use quotes, and say hello. Again, as I mentioned before, I could say, I can use single quotes also. These are both identical. The only reason they have both is because like if you want to mix and match, like if you want quotes within your string, for example, let's say I want to use quotes, hello, world in quotations. I don't know why I'm doing this. I can do that. So I have single quotes as my string limiter, and then inside I can use double quotes. I could do that vice versa also. If I want to use double quotes on outside and single quotes inside, I could do that also. I'm not going to print these strings out. We're familiar with strings. One function to know about, though, is this magic function called len. So normally in JavaScript, you have a dot length property. In Python, you don't have that for most objects or most data types. So instead, you use len, and that will give you the length of the string. So let's use my string, since I can count that offhand. It's 5 characters, so I would expect this to output 5. Yep, got a 5. So use len. You can use that on list. You can use that on many other data types. So that's length. We kind of went over string concatenation, but it works the same as in JavaScript. So if I want to add a bunch of values together, like let's say hello and world, I could use the plus sign. I could use this repeatedly, and then use some exclamations. That totally works. So this will just make hello world into one string. The key thing to remember is in Python, strings are immutable, so you're never modifying a string. And I'll demonstrate this shortly. Print string. So it made a string as we expected without spacing. It's not bad there. Yeah, so we have a string that we just built with pluses. I want to highlight that you can't modify a string. So if I do my string, I could assign it to something. I could say new value. This is totally legit. But I could also, sorry, I'm kind of jumping over the place here. I could also extract a particular character from my string. So let's say my string, my new string is what I set it to, new value. Let's say I want the 3rd character. So that'd be my second, I guess, index 2 in this. So this should print out this W. And this is totally valid. So I get this W up in my output, and that's because I'm extracting it via the square bracket. However, you cannot modify a given string. So if I want to do something like this, I'm going to get yelled at. Let's say I want to change the W to an X for no good reason at all. If I gave that a try, I'm going to get an error. It says string object does not support item assignment. So I could do this the other way. If I want to do like C equals my string 2, this is totally valid because it's reading the value on this side versus what I had before. It was assigning to that value, which is not allowed for strings. Hopefully that was clear. Let's we can do some other cool things with strings. So let's say I want to reassign my string, but I want to repeat it. You can actually multiply strings in Python. So if I want to do this 4 times, let's add a space so we're not too messy here. Get rid of this. Get rid of that. And definitely print it out. Okay. We're almost on strings here. I think you guys are pretty familiar with strings. I don't want to waste too much time on it. But so we multiply by 4, so we got 4 copies of new value, new value, new value, new value. So that's something you can do. I guess one more thing I do want to highlight is slicing and indexing. So we talked about indexing, which is just grabbing a particular value. You can also slice a string, which I'll demonstrate here. Slicing also uses square brackets, and it uses a colon operator. So in this case, if I want to get, like, let's say, the 3rd through, let's say, 6th value, I'll do 3 through 7, I believe, because I got offset by 1. Hopefully that's correct. So I get val out of there. So it starts at 3. That's not where I want to start. I want to start at 2. And 6. Start at that. All right, so I get the W, because that's my 2nd index, and it'll go up to, but not including the index 6, which is the 7th value in my string. So that's slicing. A cool trick I just want to show, if you want to reverse a string, you can use this syntax. And I'll talk about this with more with lists, but basically this is saying I don't care about my start value, end value. I want to actually go in reverse order. And this should, this should reverse my string. Quick, easy way. Yep, that looks like a reverse version. I don't know how to pronounce that, but it's reversed. So that's some cool things you do with strings. One more thing I'll highlight, and I think we're running short on time. I'm gonna stop talking about strings because I think we're pretty familiar with it. You can replace values. So let's say I want to replace value with something else. Let's say new puppy. So if I did this and print this out, print my string, what do you think will happen here? Let's give that thought while I clear my screen and run it. I still got new value here, even though I ran replace. And this is going back to the point I mentioned before. You can't modify a string. You could replace it with a new value, but you can't modify the string that you have. So this replace is actually not modifying this string. It's actually producing a new string, which I could, I could assign back to my existing string, or just say my new string if I want, equals that. And then if I output that, I should get new puppy. Yep, that's what I expected. So there's a bunch of string methods. I'm not going to go over them. Documentation will be your friend. But there's a lot of cool things you do with strings, a lot of useful methods like capitalize. You could replace, you could do regular replace, which we'll get into. A lot of stuff to talk about there. Before we move on with strings, the last thing I want to do is string formatting. And this is string interpolation. So notice I added this F before my string, and that just means that my string's going to be interpolated. So let's say the current year is, so I'm actually going to create a variable called year and give that a value of 2021. And so what this is essentially doing is taking my variable and converting that into a string. So if I wanted to output this, I'll do print my string, and that should tell me what year it is, hopefully. Yep, the current year is 2021. If I wanted to do it the other way, it would not work. So if I want to do something like my string equals the current year is, and then add year to it, if you remember from earlier, this conversion is not going to be done for me. So it's going to actually yell at me if I try to do that. Yep, got an error, type error, can't string with int. So this is a way you can kind of get that automatic conversion. Also, you could modify this here. So let's say I want to fast forward 3 years and see what the future's like. I can totally do that within these curly brackets. So it's interpreting the value between these curly brackets. So I could have more logic than just the variable in there. So this should print out 2024. Yep, current year is 2024. I wonder what the year will be like in 2024. It'd be interesting to see what 3 years from now would be, but kind of gotta wait for that. All right, so that's strings. I'm kind of tired of strings, so I'm just gonna move on. Let's get into more interesting things. Let's talk about lists. Lists are almost, I would say, I'm just going to say this, you could yell at me later. They're basically arrays from JavaScript. They're the same way, same notation. So to declare a list, I use square brackets, and I can insert values in there. I could replace my list with something else. I could say H and, I don't know, 6 and false. And you could have different types. They don't all be the same. Yeah, that's kind of how you declare a list. It's the same way you declare an array in JavaScript. So you guys should be pretty familiar with that. Another way I could create a list, maybe from a string. Let's say I have the string, what am I doing? List. So list is a constructor method that I could pass in a string, for example. So pass in Mississippi, I don't know how to spell it. Let's print out my list. So we have, let's ignore these two. I don't want to confuse you guys. So I have Mississippi, I pass into a string, but this list method is actually going to take each one of these characters and break it out into a separate item in my list, which can be useful. So I have M-I-S-S-I, each has different elements within the list. So that's kind of cool. What else can I do here? You could also do slicing. I kind of introduced slicing with strings, but they also work with lists. There's one thing I want to get out of the way. Len, as we talked about earlier, will give you the length of your list, or if you're working with a different data type, so len should work with it. Doesn't work with all data types. Like it won't work with integers, for example, but anything that has length as a concept should work. All right, so this tells me that Mississippi is 11 letters long. I'll trust that. I'm not going to count it. But yeah, there's 11 items in my array. That's what len did. Let's do some slicing. So print my list. Let's go from index 1 to index 5. So that should be the second index, second, third, fourth, fifth, because that's index 4, but not including index 5. So I think it should be ISSI. Hopefully I'm not missing something. All right, go with this. Yep, I got ISSI. So I actually created a new list. This does not modify my existing list. This is creating a brand new list for me. And that new list has ISSI in it. So that's slicing. Just to go over the syntax again, there you can pass up to 3 parameters into your list. So let's say I want to do something like, let's go 9. This will start at index 1. This will go up until index 9, but not including index 9. The third parameter is your step function. So this is actually going to skip over every other letter. So let me just give that a run. That's what I wanted to do. I think having repeat letters is failing me right now. But yeah, that did what I wanted to do. Hopefully you can take my word for it. So I got this P in here. So it's basically skipping over every letter, but since I have a lot of duplicates, it's not clear. Probably picked the wrong word for that. But that's slicing. One more thing I want to highlight, which is not possible in JavaScript, but it's kind of cool in Python, is you can actually reference from the end. So let me just use an example to make that more clear. So you could use negative indices. So let's just create a value. Value equals my list. And so if I want like the third index of my list, I will just use 2, and that'll get me this S because it's the third index. Again, we're 0-based in Python, just like JavaScript. Let's say I wanted to get this the last P in my list. I could just count it up and go all the way there, but since I'm lazy, I want to actually go from the end backwards. To do that, I can use negative indices. So negative 2 actually references this value. If I did negative 1, that would reference this value. So that's it can be useful. Again, JavaScript does not have this feature as far as I know. So if I did my list index negative 2, it may seem kind of weird, like there's no negative 2 index, but actually it's starting from the end when you use negative values. So if I print that out, just to prove to you that I'm not crazy, or I could still be crazy, but just want to show that it works. Yep, I printed out that P. All right, so that's slicing and indexing with lists. Hopefully, most of it's straightforward. Again, there's some new syntax there, like the slicing and using negative indices. Just good to know about them, get more familiar with them when you can. Next one I'm going to go over pretty quickly is called tuple. This is pretty much like lists. So the notation for that are round braces instead of square braces. I could have these values in it. The only major difference between tuples and lists is that tuples cannot be modified once they've been created. So if I have my list and that equals 3, 4, and 6, and I have a tuple 3, 4, 6, I could do something like my list. Let's say the middle index equals 88 because I like the number 88. I'm going to use my list. All right, so I have that. If I print that out, my list should be updated. All right, let's give that a quick run. All right, yep, my middle index or middle value became 88 because I assigned it right here. If I try to do that for my tuple, things are going to go awry. And this is where I get yelled at by Python. So if I try to assign that to 88, I'm not going to bother printing it out because I'm not going to get there. I got an error. I get tuple object does not support item assignment. Again, because this tuple is not mutable. It's immutable, which means it cannot change once it's been created. And this has value in certain applications when you're dealing with code that you don't want changed. Also, tuples can be used as indices because they're immutable versus lists cannot be used as indices, like in dictionaries, which we'll get to, which is a good transition, I guess. Dictionaries. Oftentimes you'll see this also called hashes or just short form dict. There's many names for it, but dictionaries, very similar to objects in JavaScript, same notation to declare it. So let's say my dictionary, let's call it my dicts. equals curly braces. So this is an empty dictionary. If I wanted to have values in it, I could do something like my, this should work, hello, and then equals world. Yep, so I could create a key called hello and then assign it world kind of dynamically. Or if I wanted to create a bunch of values like all at once, I could just do the standard notation, which you're familiar with for objects, curly braces, and do key value pairs. I could do something like hello can be my value, and world can be my key, or sorry, world could be my value, hello is my key. Need commas as usual. I could have an integer be my key, and then have that point to some other string. Donuts, I like donuts. I could have even a Boolean in here. I mean, it's kind of weird as having a key for that, but yeah. So again, you can use any immutable type as a key. So that word immutable came up again. This is where you can use tuples. Let me just put some value here. I can use a tuple here if I want to as a key, and that's totally fine. I don't know, cookies, sure. However, I cannot use a list here. So if I compile this, it's going to be fine. If I try to use a list here, it's going to say no go. Because lists are mutable, which means they can be changed after they get created. And dictionaries need immutable keys. So if I ran this, I got an unhashable type list. So just something to know about. That's why immutability can be important. Key values have to be immutable. So that's how dictionaries work. There's not too much difference, again, from dictionaries and objects. I'm not going to spend too much time here. And we do have a few more items to go over. So I'm going to kind of leave you with dictionaries. You're going to use these a lot. They're pretty similar to objects. I guess the one difference I will highlight, since I highlighted it before, dictionaries, as of, I think, Python 3.7, their order is guaranteed. So if I have hello here, it's going to be the first item if I'm going through it. And if I want to prove that, I can just print this out. My dictionary. Look at this. And I can't use a list though. You got to use a tuple. All right, so print out my dictionary. All these key value pairs looks good to me. And so those are dictionaries. They're very useful. You'll be using them a lot, just like you use objects in JavaScript. So get familiar with them, and you'll be happy in the long run. The next thing I want to go over are operators. And so I'm going to take a quick pause here. Hey, Tom, should we keep going or should we just end for discussion time?
We can end for discussion time, and okay. we can do breakout rooms if we
Gotcha. So yeah, we have a lot of material to cover today. Definitely some more I want to go over. So in discussions, I think good things to know about will be how to define a function. So I'll go over that quickly right now, just because you're going to probably be using functions for your challenges. To define a function, use the def keyword, and then you give your function name. So I might call my function my function. It could be named whatever, my whatever. You got to use round braces for input parameters. Even if you have none, you still got to have these round braces, and then you use a colon. So a colon will basically define a new block, and then so another key difference here, in JavaScript, we use curly braces to define a block. In Python, that is not the case. You just use tab indentation. So if I want to create a function here, I could do like x equals 9, y equals 66, I don't know. If I want to get out of this function, I simply unindent and just start writing my logic here, like my value equals 77. So in this case, these two values are in this function. This is my function definition. This is outside of my function definition. So tabs are how you delineate in Python. You don't have to worry about brackets. Like brackets will actually cause an error probably. This you don't need. You just need colons after functions and if statements and for loops and indentations to delineate those blocks of code. So if I had like an if statement, let me just go over if statement syntax. If x equals 9, I would have a colon and just indent. It auto indents for me in VS Code, which is kind of nice. I might just do some other stuff like let's assign y equals to 88 if that's the case. You can do else. Again, a lot of this should be familiar from JavaScript is just the syntax you kind of get used to. Y equals 77. Kind of makes sense. For loops, I'll punt for loops for discussion time. Some more material to go over. I apologize for running short on time. It's a lot to go over. But yeah, discussion time, definitely spend some time getting more familiar with Python. We will spend, I guess, more time later in the week, probably Friday, just to cover some of the stuff I didn't get to today. So I apologize for that. But yeah, hopefully you guys got a brief intro into Python. I think discussion time, hopefully we'll round out the stuff that I didn't quite get to, but functions and if statements, for loops, those are pretty similar, but there are some key differences. All right, hope you guys enjoy that intro to Python. There's more to learn, so stay tuned for more Python. We're gonna break out. We're gonna take a short break. So let's take a 8-minute break. We've been going for a while. And 11:40, let's get into discussion groups, and then we'll break for lunch after discussion groups. All right.